Hey, this is Math 8, Unit 4, Lesson 15, Writing Systems of Equations. So we're going to write some systems from real-world situations, which means you're writing your own equations today, okay? So first we begin with match each system equation with the number of solutions the system has. Okay, so remember if it has no solutions, we're talking about lines that probably are running in parallel with each other. If it has one solution, that means they're going to cross at one point there. And if it's infinite, we're talking about lines that are stacked on top of each other so that there are points all along the lines that are all possible solutions. Okay, so when we first look at this first one, we see we have the same slope, which means they're going the same direction, in this case here negative and negative, but a different starting point. One is starting at y equals plus 4, and one is starting at y equals negative 1, which means they're never going to cross, so in this case here would have no solution for letter A. For B, we have a slope of 4 and a slope of negative 2. Okay, so we have different slopes. Different slopes is a good thing. I can also need to check to make sure it's not the same equation though. So 4 divided by negative 2 is that, but negative 5 divided by negative 2 is not 7. This is going to be a one solution one because it has different slopes, okay, and they also start different places too. Here, when we look at this guy here, I am multiplying by 2, okay, so if I multiply this by 2 I get that, multiply this by 2 I get 16, okay, let's pretend I did that real quick. If I multiply everything by 2 I have 4x plus 6y equals 16. Can 4x, 6y, 6y add together to equal 16 and 17? It's not possible. There's no number I can plug in here that's going to make this work. This is going to be a no solution one, because there's no number x or y I can make this equal to two different values. It's just not possible. And finally here, if we distribute, we have 5x minus 15, okay? And so because we have the same equation, y equals 5x minus 15, y equals 5x minus 15, this is going to be an infinite number of solutions on that one there because it's the same equation. Let's take a look now at the first set of stories. It says create a system of equations and then without solving interpret what the solution of the system would tell you about the situation. Okay, so here's the first one. The first one's a little different. The rest are a little bit more clear-cut. This was the strangest one of the whole thing, at least in my mind. I just can't get my head quite wrapped around it, but that's okay. It says Lynn's family is out for a bike ride when her dad stops to take a picture of scenery. He tells the rest of the family to keep going and that he'll catch up. Lynn's dad spends 5 minutes taking the photo and then rides 0.24 miles per minute until he meets up with the rest of the family. Okay? And for a long path. Lynn and the rest were riding at 0.18 miles per minute. Okay, so in terms of the family, we could say the family seems to be going at a rate of 0.18 miles per minute. That's their rate there. But they're also starting, in this case here, they've already gone for 5 minutes at that same rate. Okay, that's the family's rate. Now dad, it says, is traveling along at 0.24. Okay, so in theory, if we set these two things equal to each other, okay, and maybe the distance here, the distance there, that would tell us where they would meet together. The solution would be the time that it takes dad to catch up with the family, looking at something like this one here. That's the idea with this first one. Again, this was a little not quite as clear. Look at number 2 though. I think you'll find it a little more just easier to understand. It says Noah's planning to take a kayaking trip. Kayak rental A charges a base fee of $15. This is group A, right? They do $15 plus $4.50 every hour. That's their rate. Kayak company B charges a base fee of $12.50 plus $5 every hour. Okay, so this one may be a little more easy to figure out our costs, right? The cost is going to be those two equations there. So I definitely have two equations here that I could set equal to each other and solve to determine what I'd find out. Now when I solve for this one, what I'm solving for is the letter H, which is going to be when the cost will be equal for both companies, right? Like how many hours is it going to be? So it's going to be, I don't know, 5 hours, 6 hours. You'd have to figure out the math to figure that out. But that's what I would find out. At what point, what value of h is finally going to make all this equal to each other? So that means, I have paid the same amount. Okay, let's look at number 3. 3 says, Diego is making a batch of pastries. The recipe calls for 3 strawberries for every apple. So that's 3 strawberries for every apple, right? Diego used 52 fruits altogether. So strawberries plus apples equals 52. Those become the 2 equations I would have. Now from this, I could use some substitution. I could substitute 3s in the place of a and solve for s, and then go back and solve for a, right? Let's do it real quick, just for fun, right? If I put 3s here, I end up with s plus 3s is 4s, and if 4s equals 52, I divide by 4, and 52 goes into there 13 times. We'd have 13 strawberries, right? I think that's right there. Let me double check there. Maybe, yep, 52 divided by 4. Yep, 13 strawberries, which means I would have how many apples? Well, I multiplied 13 times 3, right? 13 times 3, and I'd have 39 apples. Okay, and that'd be my solution for what would work for this one here. The last one, number 4, says flour costs $80 cents a pound for flour, and sugar is 50 cents per pound. An order of flour and sugar weighs 15 pounds and costs $9. Okay, so what do we know here? That I have for 80 cents for flour plus 50 cents for sugar is going to give me a total cost of $9. I'm using my dollar signs there. But I also know that the flour plus the sugar altogether should equal 15 pounds. So I have a couple things here, right? I have to find out how much flour and how much sugar would I have, to have $9 worth of that, and for the combined weight to be 15 pounds. It's again another one of these equations where I have a graph of some sort here, and I have a line going from there to there. I need to find a point at which I'm going to have an intersection so that I can have this point and say, that's where that's going to happen at there. So this would help me solve to figure out how much flour and how much sugar I would have to make both things true, being $9 of value and 15 total pounds. All right, moving down. This next one here, you have several choices, 7, and it says to pick 3 you think would be least difficult and 3 the most difficult, and then solve some of them. I'm going to go ahead and solve just 2 for right now. I'm going to solve A and I'm going to solve C. I'm going to solve A because it looks like it's pretty basic. I have y equals negative 2x plus 6 and y equals x minus 3. I'm going to go ahead and just set them equal to each other. So negative 2x plus 6 equals x minus 3. I'm going to add a 2x here, add a 2x there, so I have a positive 3x here, add a 3, add a 3, so I have a 9 there, divide by 3, and 3 equals x. I can plug that back into one of these values here, 3 minus 3 for the x one right there, and so we have y equals 0, so the solution would be 3, 0 for letter A. For letter C, this one I chose because it has some fractions, right? And so we have 2/3 x minus 4 equals negative 4/3 x plus 9. We can add 4/3 x to both sides. So common denominator, we're good there. So 2 plus 4 is 6. So I have 6/3 x over here. Add 4 equals 13. Okay, we can multiply. Well, actually I can first reduce that. 6 divided by 3 is 2. So that's 2x equals 13. Divide both sides by 2, and x equals 13 over 2. Okay, so we're good there. That's our x value. Now I can use that to plug it back into one of my equations. Let's use this one right there. So 2/3 times 13 over 2 minus 4. 2's go away. And I have 13/3 minus 4. Right? A little strange there. What's the 4 about? I can turn that into a common denominator by turning the 4 into 12/3, because 12 divided by 3 is going to be 4. So 13 minus 12 is 1. And keep the denominator the same, so I have 1/3. So my point becomes 13 over 2, comma, 1/3. That's my x value and my y value right there. So that's what I would do to solve that out there for you. And that's kind of what today's lesson is about. So take a pause there and do your homework, and then let's check it together. Okay, homework. Here we go. Kieran and his cousin worked during the summer for a landscaping company. Kieran's cousin has been working for the company longer, so his pay is 30% more than Kieran's. Last week, his cousin worked 27 hours and Kieran worked 23 hours. Together, they earned $493.85. What is the hourly pay? All right, so let's take a look at here. The cousin, first of all, we'll call him C for cousin. He gets 30% more. So remember this from before. 30% more means he makes 130% of whatever Kieran makes. Okay? So I can turn this into a decimal and call this equal to 1.3K. Alright? So that's what we know so far. Now, what we also know is that together, when the cousin worked 27 hours, so 27 hours times the cousin plus 23 hours times Kieran gave us a total of $493.85. Okay, this is the facts that we know so far. So we know that C has a value of 1.3K, and we know that 27 times C plus 23 times K equals that dollar amount there. So I can substitute this value of C for that one right there, so I have an equation with all K's. 27 times 1.3K plus 23K equals 493.85. Okay? When I multiply this out, 27 times 1.3 is going to be equal to 35.1. Okay, so this becomes, let's write this over here, 35.1K plus the 23K, which is now going to be equal to 58.1K, and that equals our 493.85. So to find the value of K, I divide that by 48.1, and K is going to equal $8.50. So Kieran's pay in this case here is $8.50. Okay, that's how we solved it. So you had to take some piece of information and use what you learned in previous units, so 30% more, make that into 130% of Kieran, turn that into a decimal, and then substitute that into our equation to solve for K. A little bit long, but it does work. Okay. Number 2, decide which story can be represented by the system of equations y equals x plus 6 and x plus y equals 100, and explain your reasoning. Because this is just a multiple choice A and B, I'm going to skip this one here and let you read through it and figure out what your solution is going to be. Okay? And let's take a look at number 3. Claire and Noah play a game in which they earn the same number of points for each goal and lose the same number for each penalty. Claire makes 6 goals and 3 penalties, ending the game with 6 points. Noah has 8 goals, 9 penalties, and 22 points. Okay. Write a system of equations that describes her outcomes. Sure. So for Claire had 6 goals, and we're going to do 6 goals plus 3 penalties equal a total of 6 points. Okay. And Noah had 8 goals plus 9 penalties for a total of negative 22 points. Okay, so now I have 2 systems of equations. Now I can take these and then we can solve for this to see what we can do, solve the thing. So let's solve this out here. What I might want to do first of all is get a P on one side. So I'm going to use this one real quick. Okay, I'm going to go ahead and subtract. I'll write up here small so you can see what I'm doing. So 6G plus 3P equals 6, right? I'm going to subtract 6g. I can't combine it with that, I just put it to the side. So 3p equals 6 minus 6g. I divide everything by 3 so that p equals 2 minus 2g. So now I have a value for p. Alright, there's a p value right there. I can use that p value and plug it into this guy right there and solve for g. So 8g plus 9 times, here's my new p value, 2 minus 2g equals negative 22. I keep the 8g and I distribute. 9 times 2 is 18. 9 times negative 2 is negative 18g equals negative 22. Combine my like terms. 8g and negative 8g is negative 10g. Subtract 18, subtract 18. That's going to be equal to negative 40. Divide by negative 10, divide by negative 10, and g equals 4. Now with g equal to 4, I can now plug it back in to solve for p. So here is 6 times 4 plus 3p equals 6. So 24 plus 3p equals 6. Subtract 24, subtract 24, and 3p equals negative 18, which means penalty equals negative 6. I'm going to divide by 3. So my goals is 4 points a goal, and it's negative 6 points for each penalty, and that's what I find out when I find that solution. That's what the solution actually means there. Alright, that's number 3. Number 4, solve this one out, set it equal to each other, so here we go. Let's do 6x minus 8 equals negative 3x plus 10. I'm going to add 3x to both sides, add 3x, so the 9x is going to be equal to, add 8 here, add 8 there, 10 plus 8 is 18, divide by 9, x is going to be equal to 2. Alright, now are we done there? Nope, we got to plug that back into our system of equations, so let's do y equals 6 times 2 minus 8. 6 times 2 is 12, minus 8 is 4, y equals 4. So our solution is 2, 4 for that one right there. Okay? Alright, and that's what we have so far. Number 5, estimate the coordinates of the point where the two lines meet. Alright, let's take a look here. So let's estimate this out. Here's our little graph, and we can see that it's meeting somewhere